Hello students, I hope you all did well in your grade 12 board examination of first term, right? Okay, I am here with the solutions for you to understand in a better way that how you did your paper and how many marks you are expecting. Suppose if you are losing some marks with the help of the key that you checked, then why are you people losing marks? Okay, let us go by this. And now the paper that I am going to talk about is SSJ1 code. Okay, our code is SSJ1, right? So this is the code that I am going to explain you now, right? So here in this paper, I feel that most of the problems are pretty much easier and of course interesting. Right, let us go by this. See the first problem, the relation R defined on N, then which of the following is a reflexive relation? So what do you mean by reflexive relation? So we have the definition of reflexive relation that suppose A is an element of set capital A, then for every A belong to capital A, then R divided by A comma A belong to R, then that relation R is said to be a reflexive relation. Now let us see what are all the relations given here and which of them is a reflexive relation. So coming to the first one is x is greater than y. Of course x comma y belong to natural numbers. Okay, x is greater than y. You take a number 1 greater than 1. Is it true? Absolutely wrong. So that it is not a reflexive relation. And coming to second one, so second one is x plus y is equal to 10, where x comma y are natural numbers. We are checking here whether it is reflexive or not, right? See, for x is equal to y is equal to 5, so x plus y is equal to 10, correct? But 5 is not only the natural number. I am going to take 2 plus 2 is equal to 4, which is not equal to 10. It means 5 comma 5 belong to that relation, whereas 2 comma 2 is not belong to that relation. So that is why this is also not a reflexive relation. And coming to third one, so third one is x into y is a square number. X into y is a square number where x comma y are natural numbers. Seems to be interesting. Suppose if you take x and y both are same numbers, because we have to check whether 1 comma 1 belong to R or not, 2 comma 2, 3 comma 3, 4 comma 4. I am taking x is equal to y is equal to 2 for example. Then it is going to be 2 into 2 is 2 square is equal to k square, because it's a square number. And like not only for 2, you take any number, 3 is equal to k, x is equal to y. So x and y are 3, then it would be 3 into 3 is equal to 3 square, 4 into 4 equal to 4 square. It means 1 comma 1 belong to our relation, 2 comma 2 is our relation, 3 comma 3 is our relation. So that every single ordered pair is a relation. Therefore, x into y is equal to k square is nothing but it's a square number, is absolutely a reflexive relation. And coming to fourth one, x plus 4y is equal to 10. If you take two equal numbers, suppose I am taking x equal to y is equal to 1. So 1 plus 4 into 1 is equal to 5. 5 is not equal to 10. Obviously this is not a reflexive relation. So the answer for the first one is going to be maps with two different elements. It means one element is only the image for two different pre-images. So that with the help of this we can understand one thing, that it is not one-to-one function. And coming to onto function. So onto function means what? Every single element of the codomain should be mapped. It means range should be equal to codomain. So what is the range of cos function? Range of cos function is -1 less than or equal to cos x less than or equal to 1, right? So it means 4 plus 3 cos x is add 4 on both the sides less than or equal to 4 plus 3 cos x, right? So when you multiply by 3, 3 into -1, 3 into cos x, 3 into 1. So 4 minus 3, and this is 4 plus 3 cos x less than or equal to, this is, you are adding 4, right? So 4 plus 3. It means 4 minus 3 is 1 less than or equal to your function less than or equal to 7. It means f of x always between 1 and 7. And 1, before 1 there are infinitely many number of real numbers, and after 7 there are infinitely many number of real numbers. It means you cannot map every single element of this codomain. Therefore, it is not onto function also. Therefore, here f is neither onto nor one-to-one function. Therefore, the answer for the second problem is absolutely D. Hope you understand? Right. So, moving on to the third one, y is equal to cot inverse x where x less than 0. This is one of the interesting problems that I found. See here, y is equal to cot inverse x where x is less than 0. X less than 0 means x takes negative values. So for me to understand it in easy way, what am I doing? Y is equal to cot inverse x. By the definitions of inverse trigonometric function, I can write x is equal to cot y, where x takes negative values. Let me take x is equal to negative 1 for my convenience. Then it would be negative 1 is equal to cot y. So can I write it as cot y is equal to negative cot 1 is nothing but pi by 4, because cot pi by 4 is equal to 1. So negative cot pi by 4, I am writing it as cot. Cot is negative in which quadrant? Of course, second quadrant is negative and fourth quadrant also negative. So in second quadrant, it is pi minus theta. So pi minus theta means pi minus pi by 4. What is pi minus pi by 4? This is cot 3 pi by 4. Right? So cot y is equal to cot 3 by 4. Then y is equal to 3 pi by 4. This is one possible value. Let me just go through our options. So here pi by 2 less than y less than or equal to pi. So your 3 pi by 4 is above pi by 2 and below pi. But here the options are given as pi by 2 less than pi less than or equal to pi is given. Pi by 2 less than y less than or equal to pi. Less than or equal to pi means what? The value of y can be pi also. Is it possible? Let us see. So y is equal to, in the place of y, if you put pi, then x is equal to cot pi. What is the value of cot pi? Is it minus 1? Absolutely no. So therefore, third option is not A. So the third option is B. You understand how to answer this? Correct. And coming to the fourth one. So fourth one is the number of functions defined from set containing 1, 2, 3, 4, 5 to set containing a comma b. So what kind of functions here? You need to find one-to-one function. When is this one-to-one functions or injections is possible? Only when the number of elements of first set should be less than or equal to the number of elements of the second set. Because according to the definition of one-to-one function, every single element of the first set should map with the second set only one time. Isn't it? So different elements of A have different images in B. So that is only possible when the number of elements of the domain should be less than or equal to the number of elements of the codomain. But here it is in reverse order, right? So absolutely it is not possible to form any one-to-one function. Therefore the number of one-to-one functions is going to be 0. So the answer for the fourth one is D. D is equal to 0. And coming to fifth one, A is given as A is equal to 4, 2, minus 1 and 1, and you are asked to find what is a minus 2i into a minus 3i. Correct? I is equal to what? 1, 0, 0, 1, right? So a minus 2i. So a minus 2i into a minus 3i is going to be, a is 4, 2, minus 1, 1, minus 2i means 2, 0, 0, 2. So this is one matrix and the other matrix is 4, 2, minus 1, 1, minus 3i. 3i means 3, 0, 0, 3. Right. So this is another matrix. Let us simplify this. So 4 minus 2 is equal to 2. 2 minus 0 is 2. Minus 1 minus 0 is minus 1. 1 minus 2 equal to minus 1. Multiplied by 4 minus 3 is equal to 1. 2 minus 0 is equal to 2. Minus 1 minus 0 is equal to minus 1. 1 minus 3 is equal to minus 2. Correct? So let's multiply both the matrices now. 2 into 1 is equal to 2 plus 2 into minus 1 is equal to minus 2. And then 2 into 2 is equal to 4 plus 2 into minus 2 equal to minus 4. Similarly, minus 1 into 1 is equal to minus 1 plus minus 1 into minus 1 is equal to plus 1. Similarly, minus 1 into 2 is minus 2 plus minus 1 into minus 2 is equal to plus 2. So what did you get here? I think you get a 0 matrix. So where is that 0 matrix? That is D. It is easy, right? So coming to sixth problem. So in this sixth problem we have matrices given. P is a matrix of order 3 by 3. Okay. So in this sixth problem, P is a matrix of order 3 by 3. So it's a square matrix such that P dash is equal to 2P plus 1. What is P dash here? P dash is nothing but transpose of P. So P dash is defined as 2P plus I. 2P plus I. So that which of these is true for P dash is equal to 2P plus I. Let us go by the options here. In the first option A, P is equal to I, for example. I means what? 1001. What is P dash? Also 1001. Let us check whether it gives I or not. Okay. So then 2 into P. P is equal to I. So 2I plus I is equal to 3I. So 3I is equal to what? 3003. But 3003 is not the transpose of 1001. So this is absolutely wrong option. And coming to second option B, that is P is equal to negative I. So P is minus 1, 0, 0, minus 1. What is its transpose? Again minus 1, 0, 0, minus 1, right? So if you substitute P is equal to I, then it will become P dash is equal to 2 into P is minus I. So 2 into minus I is equal to minus 2I plus I. What is minus 2I plus I? That is minus I. We got the same thing, right? Since P is I, P dash also negative I. Therefore, the correct option for this problem is B. Right? So moving on to the next problem, that is seventh problem. So seventh problem is also similar to this kind of problem. If the order of the matrix A is 2 by 3, so A is a matrix of order 2 by 3, and matrix B is of order 3 by 2, and matrix C is of order 3 by 3. Right? So then, which of the following is not defined? Means which of the following is not possible to solve. So let us see C times A plus B transpose. Let us go by the orders. What is the order of C here? 3 by 3. So 3 by 3 should be multiplied by A. A is 2 by 3 ordered matrix plus B transpose. B transpose is 3 by 2 is 2 by 3. So 2 by 3. When you add a 2 by 3 matrix with 2 by 3 matrix, you will again get a 2 by 3 matrix into 3 by 3 matrix. So when the multiplication of matrix is possible, only when the number of columns of the first matrix should be equal to number of rows of the second matrix. Are they same? They are not same. So the correct option for seventh problem is A. We don't have to go for checking B, C, D because already we got the option there itself. Right? And that is about seventh problem. So coming to eighth problem here. Eighth problem A is given as, so the matrix A is given as A is equal to A 2 to A. This is matrix A, and one more information is given that determinant of A cube is equal to 27. By the properties of determinant of A cube is going to be determinant of A whole cube is equal to 27. So 27 is going to be 3 cube. So what did you understand here? Determinant of A is going to be 3. This is a simple thing that you have to understand. And you have A, find out the determinant and equate with 3. So what is determinant of A? AD minus BC. A into A is equal to A square minus B into C is 2 into 2 is equal to 4 is equal to 3. Correct. So when A square minus 4 equal to 3, A square is equal to 3 plus 4, 7. Then A is equal to what? Not root 7. Plus or minus square root 7. So the value of A is equal to plus or minus square root 7. So the answer is going to be D. Right. So coming on to ninth problem. So what is the ninth problem given here? There is a simple determinant of the matrix is asked. That is, in this ninth problem, 5, 3, minus 1, minus 7, x, minus 3, 9, 6, minus 2. So this is the determinant which is equal to 0. You are asked to find the value of x. I think we can go directly by operations, so that I am directly finding determinant 5 into, let us go by the first row, first column and first row should be left out. X into minus 2 is minus 2x, this one into this one minus this one into this one. So 6 into minus 3 is equal to, 6 3s are minus 18, so minus of minus plus 18, correct. And then minus 3 times, you should leave this column as well as this row, minus 7 into minus 2 is equal to 14 minus 9 3s are 27, so this is plus 27. And then minus 1 times, leave this row in this column, minus 7 into 6 minus 42 minus 9 into x is equal to 9x is equal to 0. Now you have to simplify. So when you simplify this, what will you get? 5 into minus 2 is equal to minus 10x plus 18 5s are 90 minus, you see here 14 plus 27 is equal to 41, right? So 41 multiplied by 3, that is 3 1s are 3, 3 4s are 12, 123. And then this is minus 1 into minus 42 is plus 42, minus of minus plus 9x is equal to 0, correct. So now see the calculation. This is minus 10x and this is plus 9x is going to be minus x, and 90 plus 42 is equal to plus 90 plus 42 is equal to 132 minus 123 is equal to 0. What is 132 minus 123? Maybe 9. So minus x plus 9 is equal to how much is this? Minus x plus 3 minus x plus 9 equal to 0. Therefore, the value of x is equal to 9. Where is that? That is option D. This is a simple calculation, right? I think you don't have to use your brain much. Right. Moving on to the next one. After 9th problem, the 10th problem is given here as, so 10th problem is the inverse of, suppose this is the matrix A I am taking, minus 4, 3, 7, minus 5. So what is the formula for A inverse? A inverse is equal to 1 by determinant of A into D minus B minus C A. That is what adjoint of the matrix. So which is equal to 1 by, what is determinant of A? 4 5s are 20, minus 7 3s are 21, into D. D is equal to minus 5, minus B is equal to minus 3, D minus B, minus C is equal to 7, and A is equal to minus 4, right? So 1 by 20 minus 21 is minus 1. So minus into this matrix is going to be 5, 3, 7, 4. This is what is inverse of the matrix. 5, 3, 7, 4 is option B. So that is what is the answer for problem 10. So moving on to problem 11. See, this is quite interesting problem. Seems to be very big, but you can answer this. So the problem given here is A is equal to 1, 0, 0, 0, 1, 0. Next is not 0, 0, 1. So that is 59, 69 and minus 1. So what are you asked to find here? You are asked to find what is A inverse. So A inverse is equal to, see, if you want to find A inverse, 1 by determinant of A into adjoint A, right? So I will directly find out that 1 divided by determinant of A. What is the determinant of A? 1 into minus 1 is equal to minus 1 and minus 0. Remaining two elements are 0, so that you don't have to find. So finally 1 into minus 1 is equal to minus 1 minus 0 is minus 1 into, now the matrix. So moving on to this, you will have to take the transpose of cofactor matrix, isn't it? Transpose of cofactor matrix. So now I am taking the elements of the first row. When I take the elements of the first row, for this element, that is minus 1 whole to the power of 1 plus 1 into 1 into minus 1 is minus 1. So plus into minus 1 is equal to minus 1 here. And for this element is, this is the second element, so minus into, leave this corresponding column and the corresponding row, then product of these two, that is 0. You will get 0 here, but I am writing 0 here because I am taking the transpose directly. So moving on to this, for this element, this is 1 3 element, so that it is plus into, leave this column as well as this row, and then 0 into 69 is 0, minus 1 into 59 is minus 59, so that I am going to write minus 59 here. Okay, so and then you will get the elements. So finally what will you get here? minus 1 into 1 is equal to 1 something something, 0 something something, and 59 something something. This is what A inverse is. Now this is exactly equal to what? Once is here 1 0 59. This is 1 0 59. So what are you getting here? So I think you are getting A inverse is equal to, this is minus 1, you are getting A11 element, right? So A11 is plus into 1 into minus 1 is minus 1. Okay, these two are same. 1 0 59, you are getting 1 0 59. So the option is obviously A, right? So moving on to 12th problem. So the 12th problem here is if the function. So what is the function here given here? F of x is equal to, what is function f of x given here? This is 3x minus 8 if x less than or equal to 5 and 2k when x greater than 5. Okay, so these two are given. When these two are given, when it is continuous, then find the value of k. When a function is said to be continuous, when left hand limit is equal to right hand limit is equal to f of that value, means f of 5. Since it is already continuous, so that directly we can find out, substitute 5 here and substitute 5 here and equate them both. So that 3 into 5 is equal to 15 minus 8 is equal to 2k. Correct? So what is 15 minus 8? 7 is equal to 2k. Therefore the value of k is equal to 7 upon 2. Right? So where is that 7 upon 2? Option B is 7 upon 2. See how simple these problems are. And moving on to 13th problem. The function f of x is equal to integral part of x, where integral part of x is the greatest integer function that is less than or equal to x, is continuous at what? See, this is a straight problem from the textbook that integral part of x is not continuous at any integer value. So if it is not continuous at integer value, it may be continuous at any other value, right? See, what are the options given here? 4, minus 2, 1.5, 1. Which of these are integers? A, B, D are integers, whereas C is not integer. So therefore, our answer is going to be C for 13th problem. Here you don't have to solve anything directly, you can answer this problem. So moving on to 14th problem. So the 14th problem here is y is equal to tan inverse e to the power of 2x. Then what is dy by dx? See, dy by dx is equal to, what is the derivative of tan inverse x? Tan inverse x derivative is 1 by 1 plus x square. So 1 by 1 plus x is e power 2x. What is e power 2x whole square? E power 2x into 2, that is e power 4x. And for x, x means e power 2x, you have to find the derivative. What is the derivative of e power x? E power x derivative is e power x. And what is x there? X is 2x. What is the derivative of 2x? Which is 2. Therefore, dy by dx is equal to 2 e power x, 2 e power 2x by 1 plus e power 4x. Where is that option? Absolutely, that option is A. Right? And moving on to the 15th problem. So here 15th problem is y square times 2 minus x is equal to x cube. Then you need to find what is dy by dx at 1 comma 1. So find out dy by dx here. In order to find dy by dx, so directly I go for finding dy by dx here without transposing anything there. Y square times 2 minus x. This is in the form of u into v. So y square into derivative of 2 minus x. Derivative of 2 0. Derivative of x is equal to 1 plus 2 minus x into derivative of y square is 2y and derivative of y is dy by dx is equal to x cube derivative, of course, 3x square. But you need to find dy by dx at 1 comma 1. It means x equal to 1, y is equal to 1. Substitute here, y square is equal to 1. 1 into minus 1 is equal to minus 1. Plus 2 minus 1 is equal to 1 into 2 into 1 is equal to 2 into dy by dx is equal to 3 into 1 square is equal to 3. I have directly substituted x equal to 1, y equal to 1. Transpose minus on that side. So 2 dy by dx is equal to 3 plus 1 equal to 4. So 2 ones, 2 2s are 4. Therefore the value of dy by dx is equal to 2. So where is that 2 here? The option is A again. So that's all about 15th problem. And moving on to 16th problem here. The 16th problem given here is the angle between the tangents to the curve y is equal to x square minus 5x plus 6 at the points 2 comma 0 and 3 comma 0. Suppose this is a second degree polynomial. For example, this is a curve, and for example, this is the tangent to the function. Okay. Now the curve equation given here is y is equal to x square minus 5x plus 6. Now you need to find out the angle between the tangents to the curve y is equal to x square minus 5x plus 6 at 2 points 2 comma 0 and 3 comma 0. So first of all, y is equal to, the given function is x square minus 5x plus 6. In order to find the slope of tangent to the curve, I am going to find dy by dx. That is x square derivative 2x, 5x derivative is 5. So this is what slope of tangent to the curve. But we have two tangents. So what is the value of dy by dx at x comma y is 2 comma 0. Substitute 2 comma 0, let it be the first slope. When you substitute 2 in the place of x, 2 into 2 minus 5 is equal to minus 1. That is the slope of the tangent to the curve at the point 2 comma 0. And another one is slope of tangent to the curve at another point. What is that another point? That is given as 3 comma 0. So which is equal to 2 into 3 minus 5. 2 3s are 6 minus 5 is equal to 1, right? Now you have to find out the angle between both the two tangents. Now C1, slope of first line is minus 1. Slope of second line is plus 1. What did you observe here? So if you find out the product of these two slopes, you will get minus 1, right? So when product of slopes of two lines is minus 1, only when they are perpendicular, right? So therefore, the angle between both the two lines is pi by 2. It was given. So the option for 16th problem is A. Okay. Now coming to 17th problem, the interval in which the function y is equal to x cube plus 6x square plus 6 increases. This is straight away problem. Everybody can answer this, right? So coming to 17th problem, the function y is given as x cube plus 6x square plus 6. Increasing in which interval? For that, you need to find out the first derivative. Y dash is equal to x cube, derivative is 3x square. 6x square is 12x. Of course, this is constant. Therefore, y dash is going to be, if you take one 3x common, then x plus 3 4s are 12. In order to find the turning points, you need to equate this with 0. So 3x times x plus 4 equal to 0 means either x is equal to 0 or x plus 4 equal to 0 means x equal to negative 4. There are two turning points. Let us take two turning points on the number line. So first one is minus 4, next one is 0, this is plus infinite, this is minus infinite. Okay. Now this is y dash, right? Let us take one value c in any one of the intervals, that is your wish. Okay. Because by wavy curve method, we can figure out the other alternative intervals also. So for my convenience, I am going to take one interval. That interval is above 0. I am taking here one number c is equal to some 1. If I take c is equal to 1 and substitute here f dash of 1 is equal to, c is equal to 1 is a positive number, right? So 3 into 1 is equal to positive, 1 plus 4 is equal to positive, totally positive. So greater than 0. Greater than 0 means what? In this interval it is greater than 0. Means it is increasing and it is decreasing and it is increasing. Right? So in which intervals it is increasing? See, minus infinite to minus 4. Union, in this interval also it is increasing. So 0 to infinite. So this is what is the interval that it is increasing. So where is that interval? I hope that interval is A. So that answer for the 17th problem is A. So that way we can easily answer the problem. And coming to 18th problem. So that 18th problem here is the value of the function for which y is equal to x minus x square is maximum. So in order to find maximum or minimum, let us go by this first derivative test. Y dash is equal to 1 minus 2x. In order to find the turning point, put it equal to 0. Then the value of x is equal to 1 by 2. So at this 1 by 2, you may get maximum value or minimum value. So substitute x is equal to 1 by 2 over here. Then y is equal to 1 by 2 minus 1 by 2 whole square is 1 by 4. Half minus quarter is equal to How much is that? 1 by 4, right? So 1 by 2 minus 1 by 4 is equal to 1 by 4. So 1 by 4 is the value of the maximum for this function. You understand? And moving on to 18th problem. So this 18th problem, all these things are self-explanatory because these are the problems from linear programming. So now here, if the corner points of the feasible region of an LPP maximizing the function z is equal to 11x plus 7y at the point 0 comma 3. What is the value of z at 0 comma 3? Substitute 0 in the place of x. This is 0. 7 3s are 21. And second point is 3 comma 2. So when you substitute 3 comma 2 here, when you substitute 3, 11 3s are 33 plus something. It is already more than 21, right? So this cannot be considered. And 0 comma 5. So 0 comma 5 is when you put 0 in the place of x. This is 0, but 7 5s are 35. It is still maximum. Therefore, what is only the minimum value? 21 is the minimum value that occurs. Therefore, the option for that problem is A. And coming to 20th problem. This is 19th problem, right? So this is 19, and then we'll be moving on to 20th problem. I think this 20th problem is self-explanatory because the number of solutions of the system of equations x plus 2y less than or equal to 3. See, x plus 2y less than or equal to 3 means there is no negative value for the constant. So less than or equal to 3 means if you draw this line as well as the region on the graph sheet, then it would be towards this. And second one is 3x plus 4y greater than or equal to 12. 3x plus 4y greater than or equal to 12 means this is 3x plus 4y greater than or equal to 12 is this, right? So therefore, there is no intersection region for both of them. Therefore, the number of solutions common for these two linear inequalities is 0. It means the option is obviously A, right? So this way, we can easily answer first 20 problems. And moving on to next 20, that is section B. In this section B, we have problems given here. The number of equivalence relations in the set A is equal to 1, 2, 3. So the given set A is set containing 1, 2, 3. This is problem number 21. Okay. Now we are going to find out the number of equivalence relations. Equivalence relation is nothing but, let us consider, since they have 1, 2, 3, then R is equal to set containing 1, 1, 2, 2, 3, 3 is the best equivalence relation because it is symmetric, reflexive, transitive also. But here the condition given here is 1, 2 and 2, 1 should also be there in that equivalence relation. Let us see. My relation R is equal to set containing 1, 1 should be there, 2, 2 should be there, 3, 3 should be there. And then you include the elements 1, 2, 2, 1. Is it not equivalence relation? Absolutely equivalence relation. Because these are representing reflexive relation. Since A, B is there, B, A also there. So it is symmetric also. Since A, B is there, B, C is there, A, C is also there. So therefore it is transitive also. Therefore it is one equivalence relation. And the second equivalence relation is set containing, again I am writing 1, 1, 2, 2, 3, 3, because we need 1, 2 and 2, 3. Now what I am adding here, 1, 3 and 3, 1 that I am adding. 1, 3, 3, 1. So if 1, 3, 3, 1 are there, then 1, 1 is also there. So there are 1 and 2 reflexive relations. There is no other relation formed which is equivalence relation. So therefore, there are two equivalence relations containing the elements 1, 2 and 2, 1. 1, 2 and 2, 1. Hope you understand. So that the answer for this 21st problem is C. Okay, that is C. And coming to 22nd problem. What is 22nd problem given here? F is a function defined from real numbers to real numbers. And f of x is given as 1 upon x. So you are, and for every x belong to R. See here, for every x belong to R means you can take x any number from the real number system. Is it possible now? Because if I just think about the domain of 1 by x, there is no 0 in the domain of 1 by x as it is a real function. But domain is given as capital R directly. How is this possible to become a function? It is not a function at all. So that my option is not one-to-one, not onto, not bisective, not defined. It is not a function at all. So therefore it is not defined. The answer is D. And moving on to 23rd problem. So in this 23rd problem, what is given here? F is a function defined from natural numbers to natural numbers, and f of n is given as n plus 1 by 2 when n is odd, and the second one is n by 2 when n is even, right? So this function is what kind of function? Is it a bisection or one-to-one or onto or whatever it is? See, I have natural numbers 1, 2, 3, 4, 5, 6 and so on, and natural numbers 1, 2, 3, 4, 5, 6 and so on. This is domain and this is codomain. So now let me check which function is this. I am taking n is odd, so now I am taking 1. When n is odd, then it would be 1 plus 1 by 2. 2 by 2 is equal to 1, so 1 maps with 1. Correct? Now I am taking another odd number, that is 3. 3 plus 1 equal to 4 by 2 is equal to 2. So 3 is mapping with 2. Then what about 5? 5 plus 1 equal to 6 by 2 is equal to 3. So 5 maps with 3. Similarly 7 maps with 4. Correct? 7 maps with 4 and so on. Now when n is even means, so in this way we can understand one thing, that every single element of the codomain is mapped. Means range is equal to codomain. It is obviously absolutely onto function. Right, let us check whether it is one-to-one function or not. When n is even, I am taking 2. So 2 by 2 is equal to 1. So 2 is mapping with 1. That element is enough to say that it is not one-to-one function, right? So that it is not one-to-one, but it is onto. Where is that option? Option C is the correct option for this problem 23. So hope you understand. It is very easy to understand. Moreover, this is a straight textbook problem. Fine. So coming to the next one, that is 24th problem. So 24th problem is given as, find the value of sine inverse of cos 13 pi divided by 5. You know sine inverse. So sine inverse is defined only with minus pi by 2 to closed pi by 2. Closed minus pi by 2 to pi by 2. So this is cos of 13 pi divided by 5. Cos 13 pi by 5 can have a certain value because it is not cos inverse, right? So let us try to simplify this. Sine inverse of cos 13 pi by 5, can I write it as 2 pi plus pi by 5 2s are 10. 10 plus 3 is equal to 13. So 2 pi plus 3 pi by 5. Okay, 2 5s are 10. 10 plus 3 is equal to 13. So cos of 2 pi plus is nothing but one revolution is completed. So again you will get cos 3 pi by 5. 3 pi by 5, that is cos, but we want the answer in terms of sine, right? So that what am I doing here? Sine inverse. Cos theta is equal to sine of pi by 2 minus theta. So I am writing it as sine of pi by 2 minus theta is 3 pi by 5. In order to convert it in terms of sine. So that sine inverse of sine, how much is this? 5 into pi is equal to 5 pi, minus 2 3s are 6 pi, divided by 5 2s are 10. How much is this? Which is going to be sine inverse sine 5 pi minus 6 pi is equal to minus pi divided by 10. Is this minus pi by 10 within our interval of sine? Yes, because sine interval is minus pi by 2 to plus pi by 2 closed. So your minus pi by 10 is above that minus pi by 2, right? Means this minus pi by 10 is in between these two, therefore your answer is going to be minus pi by 10. So minus pi by 10 is their answer, yes. So the correct option for this problem is B. Easy, right? And moving on to 25th problem. So this 25th problem here is, so in this 25th problem, if the value of sine inverse x is more than cos inverse x, then x should lie in the interval. See, some intervals are given here. First interval is minus 1 to minus 1 by root 2. Let me check with this. First let me substitute minus 1. Then sine inverse minus 1 greater than cos inverse minus 1. So sine inverse minus 1 is equal to minus pi by 2. It's already there. So that it is going to be minus pi by 2 greater than cos inverse of negative x is equal to pi minus cos inverse of x. That is pi minus cos inverse of 1, that is 0. So pi minus 0 is equal to pi. Negative pi by 2 is more than pi. It is absolutely wrong. Isn't it? Now moving on to 0 to 1 by 2. So 0 to 1 by root 2. It is similar way, right? This is sine inverse 0 greater than cos inverse 0. Sine inverse 0, sine 0 is 0. So 0 and cos 0 is equal to 1. It is also absolutely wrong. And then 1 by root 2 comma 1. So sine inverse 1 by root 2 is greater than cos inverse 1 by root 2. Right? So sine inverse 1 by root 2 is going to be how much? Sine inverse 1 by root 2. Yeah. So 1 by root 2 is equal to 45. So sine inverse 1 by root 2 is equal to sine 45. So sine 45 is nothing but pi by 4. And cos inverse 1 by root 2 is also is equal to cos 45. Then this is greater than pi by 4. Correct? But if you go with the values of 1, okay, between 1 by root, we are not finding for 1 by root 2, right? So we are not supposed to, because if it is 1 by root 2, then you will get greater than or equal to. Let us just take the value between 1 by root 2 and 1. So which is possible value? More than 1 by root 2 and less than 1. If you take any number, I think sine is increasing function and cos is decreasing function within the interval to 0 to pi by 2. So sine inverse is also increasing and cos inverse also increasing. So that the correct option in this is C. Because even if you take 1 here, so sine inverse of 1 and cos inverse of 1. Sine inverse 1 is pi by 2 and cos inverse of 1 is equal to 0. So obviously pi by 2 is greater than 0. That can be one value, so which can predict that C is the correct option. And D obviously not a correct option. Therefore your option for 25th problem is C. Clear? And 26th problem given here is A is equal to cos A minus sin A as well as cos A. So in this you are asked to find A is equal to cos A minus sin A and sin A as well as cos A. So what is the information given here? A plus A transpose is going to be I. Then the value of A is equal to how much? Right? So A plus A transpose means this is A cos A minus sin A and sin A as well as cos A plus what is A transpose? Cos A minus sin A is cos A minus sin A and this is sin A and cos A. Sin A cos A is equal to I, right? So I is 1001. Now once you check, cos A plus cos A is equal to 2 cos A, minus sin A plus sin A is equal to 0, sin A minus sin A is 0, cos A plus cos A is equal to 2 cos A. So you are getting 2 cos A in the place of 1001 in the place of 1. So 2 cos A is equal to 1, then cos A is equal to 1 by 2. Cos how much is equal to 1 by 2? Cos 60 is equal to 1 by 2. So that cos pi by 3. Therefore the value of A is equal to pi by 3. Is it there in the options? Yes. Option B